Let's look at example 1 here. It says sketch the graphs of the following functions by applying transformations to the key points of the parent function and then state the domain and range of the transform functions. So to determine the parent function, I can remove all the numbers and see what I'm left with. So if I take away this negative sign, the 0.5 and the 2, I'm left with the absolute value of x. Now I have to determine the points on this parent function. If you recall from section 1.3, the x-coordinates that we're always choosing are -2, -1, 0, 1, and 2. To find the corresponding y-coordinates, we sub them into the equation here. So the absolute value of -2 is 2, absolute value of -1 is 1, and then of 0 is 0, of 1 is 1, and of 2 is 2. These I will call my old coordinates. And those are the coordinates on the parent function. Now to find the x and y coordinates on the function that I'm given, I'm going to have to identify the values of a, k, and d and c from the equation. So a in this case would be -1 here. The one's implied. K is going to be 0.5. It appears before the x. D is the number that's taken away from x. I don't see it, so D is 0. And C is the number at the end, so it's 2. Okay. And now I'm going to apply my transformation formulas to get my new coordinates. And remember the transformation formulas to find the new x coordinates. I'm going to take each of the old x coordinates. I'm going to multiply by the reciprocal of k and add the d value. So in this case, I'm going to multiply by 2 because the reciprocal of a half is 2, and adding 0 is nothing. So just I'm doubling these would give me the new x coordinates. So -4, -2, 0, 2, and 4. To get the new y coordinates from the old ones, I'm going to take each of those values, I'm going to multiply by a, and I'm going to add the value of c. So in this case, I'm multiplying by -1. So I'm making all these numbers negative, and then I'm adding 2 to them. So I end up with -2 plus 2, or 0, -1 plus 2, or 1, and then 0 plus 2 is 2, -1 plus 2 is 1, and then -2 plus 2 is 0. These are the new points, and now I can graph my function. I'm going to scale everything by 1s here. So I have -4 and 0, -2 and 1, 0, 2, and then 2 and 1, and 4 and 0. I'm going to draw lines through my points. And this would be the function y equals negative absolute value of 0.5x plus 2. Okay? And now I can state the domain and range. Okay, scanning to the right, the graph will continue growing. Scanning to the left, it will continue growing. So the domain, in this case, would simply be x belongs to the real number set. The range, however, is going to be restricted because scanning down it grows, but scanning up, it stops right here. So the highest y value looking at the graph is going to be 2, and the rest of the y values will be lower than 2. So y has to be less than or equal to 2. Okay, let's look at another example here. If I remove all the numbers from here, I'll be left with the parent function y equals 1 over x, the reciprocal parent function. I'm going to determine the points on the parent function. X coordinates will again be -2, -1, 0, 1, 2. Subbing in -2, I get -0.5 for y. Subbing in -1, I get -1. Subbing in 0 is undefined. And then subbing in 1 is 1, subbing in 2 is 0.5. These are the old coordinates. Now I'm going to identify the values of A, K, D, and C. A is the number in the numerator here, it's -2. K would be the number in front of X, and in this case 1 is kind of implied there. So K is 1. D is the number that's being subtracted from X, so we're actually subtracting -6 for us to see a +6, and C is 4. Now we're going to apply the same transformation formulas as before. So to get the new X coordinates from the old ones, I have to multiply these old values by the reciprocal of K, so multiplying by 1, which is not going to change them. And then I'm going to add -6, which is the same as just subtracting 6. So I have to subtract 6 from all these numbers, and that would give me -8, -7, I'm not going to use that one. -6. Sorry. -5 and -4. Now to get the new y coordinates from the old ones, I'm going to multiply by -2 and then add 4. So -0.5 times -2 would give me 1. 1 plus 4 is 5. And then -1 times -2 is 2, plus 4 is 6. 1 times -2 is -2, plus 4 is 2. 0.5 times -2 is -1, plus 4 is 3. And now I can graph. I'm going to scale my x-axis by 2's here. And my y-axis by 1's. So I have the point -8,5. And I have the point -7,6. And then I have the point -5,2. And point -4,3. Okay, so it doesn't look like much of a graph right now, but it's going to help us if we draw the asymptotes. Now, the asymptotes originally in the parent function were intersected at the origin 0, 0. We can find out where this asymptote moved to by applying the transformation formulas. So if I start with 0 and I subtract 6, I get -6. And if I start here with 0, multiply by -2 and add 4, I get 4. Notice how these two coordinates correspond to the values of D and C. So you can just use those values to draw your asymptotes. So you'll have one vertical line here and another horizontal line here, because this point here has the coordinates -6, 4. So that's the asymptote. So next you're going to draw your curves for your reciprocal function. Your curve should go through the points and approach these asymptotes but not cross or touch them, like this. Okay, the last thing that's left to do is just to state the domain and range. So the domain, remember, for reciprocal functions can be anything except for the values corresponding to the asymptotes. Okay, so x cannot equal to -6 in this case. Okay, we can't have an x value along this line. And then the range be anything except for, we can't have y values of 4 here. So that's how you would state the domain and range for this reciprocal function. Let's do one more example. We have the square root function. So that's our parent function here. I'm going to do a table to start to get the points on the parent function. These are the old coordinates. And again, when we try to take the square root of -2, we get an error message. -1 gives us an error message. So we're just basically finding the square roots of 0, 1, and 2. Square root of 0 is 0, square root of 1 is 1, square root of 2 is 1.4. Now they're determining the a, k, d, and c values. A is 1/2, k is 4, d would be -10 in this case, and c is -3. Now we can apply our transformation formulas. So we're going to take these x coordinates and we're going to multiply by the reciprocal of k. So we're going to multiply by 0.25 or 1/4. And then we're going to add -10, which is the same as subtracting 10. So 0 times 0.25 is 0 minus 10 is -10. 1 times 0.25 is 0.25 minus 10 is -9.75. 2 times 0.25 is 0.5, minus 10 is -9.5. And now we're going to find the new y coordinates, or where these old y coordinates move to. We're going to multiply by half, or 0.5, and then we're going to add -3, which is the same as subtracting 3. So 0 times 0.5 is 0, minus 3, -3. 1 times 0.5 is 0.5 minus 3, that's -2.5. And then 1.4 times 0.5, that's 0.7. 0.7 minus 3, -2.3. So now we can graph. I'm going to scale by ones here. Everything's going to be kind of tightly together. So -10 and -3 would give me this point here. Then -9.75 and -2.5 give me this point here. And then -9.5 and -2.3 would give me this point here. Okay, now you have to realize that it would go this way because the point 0, 0, okay, was the end point in my parent function. So it kind of, if I draw it over here, this is where the end point was. So this point 0, 0 now moved to coordinates -10, 3. So this is where the point would be. And then I'm going to draw the curve through the other 2 points with the arrow on the other side. Now for the domain. I scan to the right, it's going to continue growing, but to the left, it stops here. The x-coordinate of that point is negative 10. So x belongs to the real number set such that x has to be equal to 10, negative 10, and then the rest of the x-coordinates have to be greater than negative 10 because they're all to the right. For the range, scanning up, it's going to continue growing. Scanning down, it's going to stop over here at an x-coordinate of negative 3. Sorry, a y-coordinate of negative 3. And then the rest of the y-coordinates will be higher than that value. You can even tell from the table that they're higher. So we'll write y has to be greater than or equal to negative 3.